Alright, today we are looking at domain and vertical asymptotes of our rational function. The domain of our rational function is looking at all the x values that we can use. Now in rational functions, because it has the denominator, we can use all x values except for those that make the denominator equal to 0. In most situations, you're going to have to factor to find those numbers. Vertical asymptotes are the lines in our graph, vertical lines in our graph that our graph approaches but never actually touches. They are going to be very closely related to our domain, as you will see soon. So if we look at this first example, that f of x equals 1 over x plus 3. We know from yesterday that looking at our graph, this graph is going to be shifted to the left 3. So at negative 3, we'll have our vertical asymptote. The horizontal asymptote will still be there. And our graph will look something like this. Okay, knowing this, we know that our domain is everything but where x is equal to negative 3, or where x is negative 3. And if you notice, if we were to plug negative 3 into my equation, that would make my denominator 0. So negative 3 is where we cannot have an x value. So in inequality notation, we would just say x is not equal to 3. Interval notation, where we use our brackets and parentheses, we're going from negative infinity up to 3. We're not including 3, so we're going to have to union that, because then we start back up at 3 and we go to infinity. So in interval notation, we'll have negative infinity to 3, union 3 to infinity. Okay, we're going to have to write them in both notations, both forms for a while now. Our vertical asymptote, which we looked at in our graph, vertical asymptote occurs here at x is equal to negative 3. It's a vertical line, so it's x equals negative 3. So if you notice the relationship, our domain is where x is not equal to 3. Our vertical asymptote is at x equals 3. On the second one, we've got x squared minus 5x minus 6 minus 5x minus 6 on the bottom. In order to find what makes that 0, we're going to have to factor. So we'll still have the 1 over. We're looking for multiplies to be negative 6, adds to be negative 5. If you have to think very carefully on this, multiplies to be negative 6 would be negative 6 and 1, and that adds to be negative 5 because we only want one negative in there. So x minus 6, x plus 1. If we think about that, I'm not going to draw the whole graph out because we haven't really talked about what happens when we have more than one vertical asymptote. But if you think about it, this x minus 6, what makes this 0 would be positive 6. What makes this 0 is negative 1. So that means we're going to have vertical asymptotes, oops, I missed completely, at positive 6 and at negative 1. So 6 and negative 1 are 6 and negative 1 are where my function is undefined, so where my domain cannot be. So x is not equal to negative 1 comma 6. And you always want to go in order from least to greatest. So in interval notation, our graph is going to go from negative infinity to negative 1. We can't have negative 1, then it'll go to 6. We can't have 6, so then we will go to infinity. So it'll look like negative infinity to negative 1, not including negative 1, union, negative 1 to 6. We go from here to here, union, 6 to infinity. This is where kind of drawing in your asymptotes, even if you don't look at any of the rest of the graph, just having your asymptotes in there will kind of help you see where your domain and interval notation goes. Our vertical asymptotes, which we've looked at, those areas where our rational function is not defined, this point would be x is equal to negative 1 is our first vertical asymptote. The other one is x is equal to 6. Okay, on this next function, we've got 15 over 2x squared plus 6x. Notice on this one we've got a 15 on top. We're not going to worry about the numerator right now. The numerator will affect our horizontal asymptotes, which we're going to talk about later. So for right now, you just kind of ignore the numerator. We're just going to factor the denominator. We've got 2x squared plus 6x. Both of those are divisible by 2, and both terms have an x in them, so we're going to factor out the 2x. When I factor out the 2x, I'll be left with x plus 3, because if I multiply this out, we get 2x squared plus 6x. So if we think about the things that make this 0, what would I plug into this x to make that term 0? If it helps you to put it in parentheses, that's fine. So if I were to plug a 0 into 2x, then that would give me 0. So 2 times 0 is 0. So my first point that would make it 0 would be 0. If I plug in -3 in here, that would make it 0. So if it helps you to draw it over here, here you've got -3 and 0 would be those points that make your domain undefined. So our inequality notation, x is not equal to -3 or 0. Interval notation, we're going -infinity to -3, union, -3 to 0, union, 0 to infinity. Okay, so from -infinity to this -3, you go in between them, and then from 0 forward. Our vertical asymptotes are those two places that are undefined. So vertical asymptotes will be x equals -3 and x equals 0.